For centuries, people in the Mediterranean have known how to build their houses in a way that best uses the powers of nature. They knew how to create shade and build with materials that help to keep their homes cool in the summertime. But in these fast-paced times, this knowledge seems to have been forgotten. Poorly insulated glass facades, concrete buildings with no insulation, and energy-hungry air conditioning units, telltale signs of short-term thinking and building. By 2020, more than 320 million people will live in the southern and eastern Mediterranean, an increase of 30% in just 20 years. This fast population growth is mainly affecting urban centers. Together with a rising standard of living, it's pushing up energy consumption. Climate change is a threat to nature and wealth, a ticking time bomb.
It's true in the southern Mediterranean region, the consumption per capita of energy is far less than in Europe or in Northern America. But energy prices tripled within nearly 1 year. So that's why Enec, financed by the European Union, supports these 10 pilot projects just to show it's technically feasible, and second, it may be very profitable.
But climate change and high energy prices are forcing people around the world to think again, including in the southern Mediterranean. How can energy be saved? Where can renewable forms of energy be used? We set out on a search for good ideas and sensible solutions. Our discovery tour through the southern Mediterranean starts in Rabat, the Moroccan capital, at the local Faculty of Architecture. Building work has begun on a guest house. It's designed to be a low-energy building with a solar installation and heat pump that can either heat or cool, depending on what's needed. It will consume 74% less energy than a conventional house. The construction costs are about 25% higher. It will pay off in almost 10 years. The Enec program, run by the GTZ and financed by the European Union, will cover the cost of the additional investment. The building is one of 10 pilot projects in the southern Mediterranean. To understand how houses can be cooled without wasting energy, even in such extreme heat, our journey takes us to the Sinai Peninsula in Egypt. Is it perhaps possible to use the sun for cooling? In the holiday resort of Sharm el-Sheikh, there's an interesting solution. The local environmental authorities have launched one of the Enec projects here. In the summertime, temperatures climb to 45 degrees. In these evacuated tubes, water is brought to boiling point with the sun's heat. The so-called absorption chiller needs boiling water to create cool air, using a technique that's similar to a fridge. It's lowered the energy consumption by 47%. But for tourist regions in particular, technologies like solar cooling are of great interest.
Market development is the overall game of the whole project, because individual pilot projects do not change anything for the country. So actually there are some markets already developing. If you take the example of energy-saving bulbs, this is profitable in nearly every country of the region.
In Algiers, one can already buy energy-efficient bulbs. Energy prices here are the lowest in the region. The government is demonstrating possibilities for energy efficiency with this 3-room rural house. The orientation towards the sun saves energy, and at no cost. The elongated roof and a roofed veranda provide shade in the morning and prevent it from becoming too hot. At noon, the short pitch of the roof keeps the absorption area to a minimum. The almost windowless west side of the house is ideal. It keeps the heat out in the afternoon. With more than 250 days of sunshine a year, it makes sense to use solar energy for warm water and heating. This country house boasts an impressive 57% energy saving thanks to the heat insulation used. Here, the investments make up 45% of the construction cost. They only pay off after 67 years, though, because energy is highly subsidized in Algeria. But primary energy consumption for heating, cooling, and providing power to our homes is at up to 40%, one of the main causes worldwide for climate change. Throughout the region, we find many attempts to use renewable energies or improve insulation standards. But the measures are only worthwhile economically when the political framework is right. The upside is that there's a comparatively large potential for energy savings in the construction sector. Considering that houses are built to last at least 50 years, an investment return period of 10 years seems reasonable. Unused energy is still the cheapest energy there is, so to say, especially for the CO2 footprint of a whole nation. And especially when energy has to be bought at high world market prices, as is the case in Lebanon. In Jakarta, with a population of 75,000, 80 kilometers north of the capital Beirut, we find an example which is likely to catch on soon. The Centre Hospitalier du Nord is a privately run hospital. The electricity supply is in the hands of the state. Because it's unreliable, the hospital has to run expensive diesel generators for backup. The state electricity supply simply doesn't meet the needs of the country. To compensate for this, the hospital has an energy management system which ensures that electricity is only used when it's cheapest. This saves energy. Conventional light bulbs were replaced by low-energy bulbs, and the roof insulation was also improved. Such relatively small investments pay off after a year already. In Sakhnine, we see a revival of traditional construction methods and new technologies. Light domes, skylights, stone walls, and shaded courtyards have been the norm for centuries here in order to keep houses cool. In these 12-meter-high wind towers, known as malkavs, cold air falls to the ground and cools the adjoining rooms. An improvement in solar technology, it's now cooled with water, further increasing its performance. We're moving on to Damascus, the capital of Syria. The narrow alleyways stay cool, and the black and white facades absorb and reflect the heat in equal measure, as does the 18th century Sibai house. In the suburbs of Damascus, a gigantic building boom is underway. This apartment building will soon be home to many low-income families. Yet the building will have double glazing. A solar thermal system will heat the water for free, and the walls will be well insulated. On the whole, the building will use 63% less energy than those around it. The state building company has factored in an additional cost of 35%. Renewable energy cannot just be harnessed from the sun, but also from the earth. It's called geothermal energy, and it's being used in Ramallah, the biggest city of the West Bank. This house is also well insulated and has double glazing, but the special thing about it lies beneath the ground. Geothermal energy is used for heating purposes.
Right now, we are literally developing the geothermal market within the entire Middle East, North Africa region. I believe the potential for geothermal energy is enormous for our region, and it's really up to us how far we want to take it. Our region is in a unique position as a developing region to incorporate renewable energy into our projects as we build them. And that allows us to create a sustainable future and a better future for our generations to come. And it's really up to us. We are the responsibles. Our leaders, our private sectors, our governments are responsible to take the initiatives to incorporate technologies like geothermal.
This project's short payback period of 6 years makes it particularly interesting. And the fact that this can create lots of new jobs is evident here in Gebze, near Istanbul. Since 2003, more than 6,000 workers have received training in how to insulate walls professionally. The demand for skilled workers is growing fast. In the last 4 years, some 20 million square meters of insulation material were used in new homes. The pilot project in Turkey also uses geothermal energy to heat and cool. The system uses 27 holes, each 100 meters deep. The measures add an extra 25% onto the building costs, but in less than 12 years, the RMI will have recouped its investment. In places where the sun is hot enough, it even makes sense to convert a whole villa if the framework is right, and if people take a holistic approach to buildings, like here in Aqaba, Jordan's gateway to the Red Sea, a port city, and another growth region in the Middle East. The design and positioning of this residential villa is entirely focused on saving energy. The bedrooms and terrace face north and stay cool in the summer. Double glazing is standard. The windows are shaded by stone ornaments. A solar cooling system is installed. Energy consumption is saving 85% compared to conventional buildings. It's a model project worth copying. On our tour of the region, we've come to see how important it is to factor in the true cost of energy and to have the right legal framework in place to encourage investors and spur the growth of new emerging markets such as the solar market. Building with greater energy efficiency in mind benefits the whole of society. It promises greater tax revenues and more sustainable jobs. It's also an important contribution to increasing a country's competitiveness. With better energy efficiency and the use of solar, wind, and geothermal power, we're also making a vital contribution to climate protection.